Hello, everyone. My name is Patrick. I'm a developer advocate at Apollo GraphQL, and I do a lot of GraphQL, mostly because I created a library a few years ago, and we're going to see that more into detail. But today, we're going to take a look at that, and also we're going to understand what GraphQL is and why you should use it, and when you should use it, maybe. So let's start with that. What is GraphQL? GraphQL is mainly a query language for API, so it allows you to create an API for your application that can be queried by multiple clients. It could be a mobile application, it could be a website, and so on. And one of the key points of GraphQL is declarative. So you only get the data that you ask for. So instead of having to find data in multiple endpoints, you only send a document, and then the server is going to return the data for you. So let's see an example of that. So this is a query in GraphQL. It starts with the operation type, which is query. There's multiple ones. We're going to see that as well. And then we're saying, I want to fetch the users field. And then for every user, I want to fetch the age and the name. And then the backend receives this query, reads it, and then it does all the magic to fetch the data for you. And it can get something like this. So it's exactly the data that you requested. So I guess that kind of makes sense. But what kind of problem does it solve? So GraphQL was created by Facebook, I think in 2013, and then it was released as open source in 2015, and now it's not owned by Facebook anymore, so it's a fully open source kind of language or specification. And it was created to solve some of the problem of REST API. So I think at the time Facebook was entering into the mobile application market, and they were building REST APIs for using the apps on their API, their data on the mobile applications. But they had some issues. Like the main two issues that they found is underfetching and overfetching. Underfetching is basically when you have an API that doesn't return enough data. So for example, here we have this page that shows a user name, their age, and then a list of blog posts. And you can have an API that looks like this, which is a quite nice API using all the best practices of REST. And it's using, for example, the links to give you more information for additional data. And so you can see that you can get the data for some of these things, but then if you want to fetch the post, you need to do another call, which is not ideal because it adds latency to your application. So every time you do an API call, there is more work to be done, and it also requires more compute power on user devices. And most importantly, it also requires quite a bit of orchestration on our side. So when we're showing this up, if we're doing 2-3 API calls, we need to basically decide what happens while it loads if one of them fails, and it's quite frustrating. And we could solve this by updating the endpoint to return more data. So, for example, we can change this endpoint or create a new one to return exactly the data that this page needs. It works for simple things, but it doesn't really scale well. Different views, different clients are going to use the API in different ways. So you might have some clients that use just some fields of that, some other clients that need more, and you tend to either build an endpoint that returns all the data possible, or you tend to build a lot of different endpoints for different use cases, which is quite hard to maintain. And this also leads, especially if you build like a big endpoint, it leads to bigger download time. So your user is waiting for more time to load the data. So it's require more compute power, and that's I think it's quite important because we're trying to build application for our users, and we need to try to deliver the best experience for them. So how does GraphQL solve these problems? So as we mentioned, GraphQL allows you to specify exactly data that your API needs, your client needs. So for example, for our previous REST API, the equivalent GraphQL API could look something like this. So we have a query, we're fetching user with ID of 1. So GraphQL also allows you to specify parameters to every field, and then for fetching the age and the name for this field. And if you want to fetch the blog post, pretty simple. We add the blog post here. We can also specify I only care about the last 3, and then we want to fetch the title. And that's basically it. So GraphQL is going to read this and it's going to fetch data for you. And that's quite nice because you don't really need to worry about where the data comes from anymore. In GraphQL, there's only one endpoint called /GraphQL. You do a request there, and basically the server is going to go and find the data for you based on the API specification. So let's see how this works in kind of practice or under the hood. So every GraphQL server has a type schema. So this schema is basically what defines what exists in your API. It defines all the data that a client can retrieve or the operation they can do. So let's see an example of the most basic GraphQL schema. So there is one here that only has one type and one field. So the type here is called query, has one field called hello of type string, and these exclamation marks means that this field is always going to be available. It's never going to return none. So it could be any string or empty string, but it's never going to be none. And the other thing to notice here is that this query type here is actually quite important because GraphQL has a way to define an entry point by name. And you can customize them, but normally it's just a query. And basically every GraphQL schema has one type called query, which is the entry point of all your data. So if you're fetching some data, it's always going to come from the query. And then we can use this schema by doing a query operation and selecting for the hello field. And you can also have other entry points, so for mutating and subscribing to event. So this could be a more complete example where you have a query, which is the entry point for doing any kind of query operation. So you can fetch all the data from there. Then there's mutation, which allows you to do anything you would do with a post request in REST, for example, like deleting data, creating users, and so on. And then the last one is subscription, which allows you to subscribe to events. It usually works with WebSocket or server-side events. We're also going to see a demo of this, which I think is quite nice. So let's get back to our user example. So we want this query, and the schema for this query is basically going to be this. So we have a type query where there is a user, which accepts an ID as parameter and returns an optional user. So there is no exclamation mark here, which means that this user can return none, because there might not be a user with this ID. And then the user has a name, age, and a list of blog posts. And then there's a type blog post, which is only a title. This is obviously like in a proper application, it's going to have a lot of more fields and types, but this is the minimal schema for this example on the left. So, what is so special about GraphQL? So we've seen that it solves some issues of REST. But I think we almost passed out at this point, because there are some nice things that the fact that GraphQL is type safe by default allows. So, some of these things you can do with REST APIs, you can use OpenAPI, but the fact that GraphQL has this schema built in by default, I think is quite important because it enables to basically have a great developer experience using some tools that I'm going to show you now in a second. One of these tools is called GraphQL, which we're going to see in details, but it's basically is an IDE that allows you to do GraphQL operations in when you want to test an API. So it has a way to craft a query, getting the results, and then also seeing the documentation. Another tool that's really cool is called GraphQL Inspector, which is almost like a linter for GraphQL. It allows you to do checks on your API for making sure that your API, for example, has description for all the fields, all the queries, and it also doesn't have any breaking changes between updates, because that might crash your application. And there's many other tools. I should probably make a list at some point, but I think where GraphQL really shines, it's mostly on the client. So if you're building front ends and use one of the clients, for example, Apollo client or URQL, they make your life so much easier because you basically set the client once and then you just say the data you wanna fetch, and that's just done in a couple of lines, which is really neat. So let's see a demo of this. So I did build a Django application that uses Strawberry to fetch the data from database and also from other places. So this is the tool I was mentioning. It's called GraphQL. On the left has a editor, so you can type and you can craft queries. On the right has the results. And then you have docs, so you can use this to basically navigate your schema and see all the information that are available there. It also has this explorer, which allows you to quickly create a query. So for example, here we can create a query for users and fetching the full name. So if I run this, I'm going to get a bunch of users. Then if I want to add the last, let's see, 2 blog posts, I'm going to get the content and the title. I can do that pretty quickly. And also I think it's quite nice to see there is a code example. This field is actually not coming from a database, it's coming from a REST API, which just returns a random quote. here. So I wanted to show this because it's quite important to keep in mind that GraphQL doesn't really care about where the data comes from. It can come from anything. Actually, it's a common pattern with GraphQL is to actually wrap REST APIs and into a GraphQL API, so it's easier to work with them. And then the other example I had is this, the one for subscription. So here we have a subscription that allows you to listen to comments, and then we have a mutation that allows you to create a comment. So if I subscribe to the subscription, I'm not going to get any data straight away because this is actually essentially a WebSocket connection, and then it's waiting for data to be sent. Here we have the mutation. When I send it, you can see there's the comments appears here almost immediately, and I can change the message. Say, look like in Estonia. You can see that this changes on every time there is a new comment. Again, this is a very basic API. It doesn't really provide more information, but you should get more information here. Another thing that I think it's important just showing is that when you use GraphQL, as I mentioned, there is only one, I don't know if this is big enough, there is only one endpoint. So every time I send a request, there's going to be a request done to the GraphQL endpoint, and by default it's a post request. So this could be changed to use get as well for performance reason, but by default is post. And then basically what you, if I can show, the payload is here. You're basically sending this query, and then the server is going to figure out where the data comes from. Cool. So that's the demo. So we have some ideas on how we can use GraphQL APIs and maybe why they're cool. Let's see how we can implement them using Python. And this is where Strawberry comes from, which is a library I created, I think, almost 4 years ago, mostly as an experiment. I wanted to see if we can use modern Python features to build GraphQL APIs. And it was a side project at the moment, and now it's something I spend a lot of free time on because there is quite a few people using it, which is nice, but also sometimes a bit depressing because I need to fix bugs. But there's not many bugs, so that's good. So Strawberry allows you to create GraphQL APIs using Python type-ins. And let's see what are type-ins, because there may be, we talk about them quite often, especially in the last few years, but maybe there's some people that don't know what they are used for. So type-ins are newish. I think Python 3.5 added them. It's a new feature of Python that allows you to annotate Python code with types. So for example, here we have this function called getUsernames, which has two parameters. One is called IDs, which accept a list of integers, and then the first, which is an integer and it has a default value of 10, and then returns a list of strings. When you're running this code in Python, Python doesn't really care. So it's almost like you wrote the code like this. But the fact that you're annotating your code, it gives you some benefits. First, it's easy to understand what this function needs. So for example, I know that IDs should be a list of integers. It's not a list of strings or something else. First parameter is almost obvious, but it's always useful to have it. And then you know that it's always going to return a list of strings, and they're always there. But then when you combine this kind of documentation feature plus using a type checker like MyPy, you can basically make sure that the code that you are about to run doesn't have any type errors. So for example, here you can see I'm trying to use these getUsernames and passing a list of parameters where one is a string. If I run MyPy or PyWrite, other type checkers, I can get this error without even running my Python code, which is quite nice, and it's been very useful to me because these are some of the things you might write tests for to make sure that nothing bad happens or you get a nice error when you do this, but you don't have to do it because with MyPy is basically built in. But the other cool thing is that type-ins can be used at runtime, and I think this is probably one of the best features, at least to me, of type-ins. So for example, in this function here, we have the A parameter and then the return value, which is a string. And when I use the dunder annotation dictionary, I can see all the types for this, the parameters and the return time. And this is basically very powerful because it allows you a lot of use cases. For example, there are libraries that actually do actual type checking runtime and other things, which is quite neat. But it's basically what makes Strawberry possible. So let's see how this works with Strawberry. So let's say that we want to build this basic GraphQL example. This, it's a type which, if you're familiar with Python, you can see that it maps quite neatly to a query, and then the field maps to a property on the query. And this is how you can define properties on Python classes using type-ins. Then the magic happens with this strawberry type decorator. And if you use data classes before, this is exactly the same thing. We use data classes under the hood. And basically, what this decorator does, it reads all the type-ins, and then it creates a GraphQL type for you, plus all the data classes things. And then the last thing we need to do is we need to create the GraphQL schema passing the query. This is mostly to make it, to basically tell GraphQL what is the root type, which is the entry point. Because you might want to change the name of this, but you still want to be able to call the hello field from there. Okay, so we have defined the schema, but what about the data? So as I mentioned, GraphQL is kind of agnostic from what you're using, but you still need to fetch data somehow. So you do this using a concept called resolver, which are basically Python functions. So for example, here, we want to say that every time I'm fetching the hello field, I want to return hello there using this hello world function. And the way you do this in Strawberry is by using the strawberry field function, which is similar to data class.field, and you pass the resolver. And so this basically tells GraphQL to always call that function when the field is requested. So let's see an example more complex with the API that we were looking at before. So here we have a query that with a field user that returns a user none, so an optional user. And then we have a getUser by ID. And here, the only difference that we are now specifying a parameter, which is ID. And ideally, this would do a call to our database, but to keep the slide short, so I didn't do that. And then same thing as before. You pass the resolver to strawberry.field, and then Strawberry does all the magic to combine this together. And the important thing here to notice that Strawberry knows that Python functions have parameters, so it gets all the parameters from the function and it passes them to the GraphQL API, which is quite nice and quite easy because it allows you to reuse all the Python things that you have. So this is pretty much it for seeing how Strawberry works, how the API is. So let's see a bit of code just to see this a bit more in depth. So I have this is a Django server, which is running here, and all the code here, which is not this, is this. It's written, it's a bit bad because I changed laptop and I forgot to commit the code for my other talk, so I wrote it yesterday. But it's basically, you don't have to be familiar with Django because I split things into parts. So there's this EE folder, which has only the settings for Django, so it doesn't matter too much. Then there is a database folder, which has the models, so the database tables for our user and our blog post, and then has a couple of functions to fetch user from database. So there's a couple of things here that might be a bit strange because I'm using async, but that's again something you don't really need to worry about if you're not using Django, if you're not using something else. All the important things are inside the API. So there's the schema here, which has the 3 entry point that we're talking about, query, subscription limitation, and then the schema. So let's take a look at the query. So this is exactly what we see now. So there is a user field that returns a list of users, and then we pass in the getUser resolver. And so let's take a look at the getUsers. GetUser resolver. So here we're doing nothing too crazy. We're just checking that the parameter is not too big, so just to make sure that the user don't try to fetch a lot of data. Ideally, you would do arrays here. I was lazy a bit to do something proper. Something to notice here, since we're using database, I'm fetching the data from database, and then I'm doing something that might be a bit strange or annoying to some people. I'm converting the data that I'm getting from database to the GraphQL type. So there are some people that like to just return the database instance. I don't really like that because it's basically you kind of sidestepping the type checker, so you're not really using the proper types. And also you should not expose your database directly with GraphQL or any API per se. And so what I've done in our types here, I do have a small helper that basically converts a Django model into a user type here, which is basically this, just doing a couple of assignments here. And also, I'm using full name and I'm using first name and last name just because I wanted a different kind of API. Yeah, hopefully that's clear. The other thing that I think it's cool now that we've seen the user type is that this user type has a blog post field, which also has a resolver. And in GraphQL, you can have resolvers in any level. So you can have fields of fields that also have resolvers. And that's quite useful if you have connections from, for example, a user, you want to fetch a list of blog posts, you want to fetch something else. This allows you to basically have a custom function for every field. By default, GraphQL or Strawberry, they basically fetch the information from the instance. So for example, for full name, it would do a get attribute on the current user with the full name. Let's see. The other thing, yeah, blog post is similar, has a quote field, and this is where I did a different resolver that is fetching data from an API. This is something you shouldn't do. It's just fetching the API without doing any error checking, just to, and also not caching any data. But this is mostly to show you that, GraphQL doesn't really care where the data comes from. It could be anything, and it works. What else? Oh yeah, for the subscription mutation, it's not much different from resolver for fields. At the end, GraphQL has this concept of types and resolvers, and it's the same for mutations and subscription. The only difference here is that I use this different syntax for defining a resolver and a field all in once using the decorator, but this is exactly the same that we had before. And here in this mutation, we accepting an ID and then a message. And then I'm using Django channels here, so I'm using the info object here, which is basically almost like a request. And then I'm using group send on the Django channel to broadcast this message to the group. And that's basically it for just creating a command and sending with Django channels. And then for the subscription, it's similar again. The only difference here is that we're using anything generator. Basically, we're telling I want to kind of iterate over something and return that data all the time, every time there is a new message here. So I'm subscribing myself to, I'm adding myself to the group, and then I'm listening to the article comment event for this group. And then every time there is a message, I'm yielding it back to the subscription. So this is how all the data comes back to the front end. So what we've seen before here in this case. So every time there is a message, it comes back here. And at the moment, Strawberry supports WebSocket in multiple libraries. I think FastAPI is solid, and also Django channel since, I think, a month ago. Ideally, we also want to add server-side events support at some point, because it probably makes more sense for these kind of things. But it's I think it's really cool that we have this. Also, thanks, Andrew, for Django channels. It's really nice. Maybe the last thing I can show you from the code here is just the URLs. As I mentioned, there is only one GraphQL endpoint, which is using the async GraphQL view. So we have two views for Django. One is async and one is sync, mostly because there were some issues in there's still some, well, no issue, but things you need to do to use the database in the async context. And async in GraphQL makes a lot of sense if you want to do some optimization, if you want to talk to HTTP API, so you might want to use that. Cool. So, just let's do a recap. So we've seen how Strawberry uses type-ins for creating GraphQL schemas. We've seen how you can use Python function, a resolver, so as a way to return data to the GraphQL API. And we've also seen how we can use parameters on resolvers on the function to basically add the parameters on GraphQL. And we've seen what GraphQL is. And hopefully, you're curious, you want to try and, maybe you want to ask me questions about this. I'm quite passionate about GraphQL, mostly because I really enjoy using it on the front end. There are some nuances on the back end. So it's something relatively new. So it doesn't have the same, I guess, age as REST. So there are things that are more difficult in GraphQL than REST for sure. I don't know, the reason why I like GraphQL is also, it's for the front end, because it makes your life so much easier if you want to build a mobile application. You don't really have to deal with multiple endpoints. If you want to learn more about GraphQL, I'm going to do a workshop next month, DjangoCon Europe. I don't know if they're still selling the tickets or if it's remote. That's something I forgot to check. But ideally, I'm going to write down all the things I'm going to talk about, because I think they are quite useful. So there's going to be things about performance, authentication, monitoring, which are different in GraphQL. So I think that's going to be valuable. So even if you're not able to come to the conference, or if if there is no video, hopefully at some point I'm going to write it down. But if you want to know more about Strawberry, you can go to strawberry.rocks. The domain .rocks is mostly because it was cheap. It's a word that it's very difficult to find a nice domain, so it's cool. Anyway, thank you very much for listening to me. If you have any questions, just ask me now or later, or just send me a tweet. Thank you.
Yes. So thank you first for the presentation. Quite interesting. I hadn't heard of this Strawberry library. Is there some story behind the name of this?
Yeah, everyone asked me about that. I wish I had a good story. It's just something I came up with randomly. It's just I think it was summer probably when I came up with the name, and I wanted something fresh. Yeah.
Well, it's a very, very fresh fruit.
I mean, some people think that it's about the Beatles, but unfortunately it's not, because there's also strawberry fields in it, I think. So maybe
yes.
should just
one technical question here is, how compatible is it with Pydantic?
Ooh, that's a good question. So we do have support for Pydantic. It's kind of marked as experimental, mostly because I personally don't use it, so I don't have time. I'm not going to be quick at fixing bugs. So there is a couple of people maintaining that. Yes, it is compatible. So you can do almost everything. So basically, if you have a Pydantic model, you can convert it to a GraphQL model using strawberry.experimental.pydantic. And that works. There might be some small edge cases, I think mostly related to when you have maybe generic stuff, or if you have some nested types. Other than that, it's been used by a couple of people in production, but I don't know if they needed to do some workarounds. But yeah.
Good to know. Is GraphQL mainly an optimization for high query rate situations, or why should we worry about overfetching?
Yeah, that's a good question. So to me, the reason to use GraphQL is not really this, solving the overfetching and underfetching problem at this point. It was a good reason at the beginning. It's a good way to kind of sell it to maybe your manager. To me, it's more about the developer experience. It kind of gives you this this nice tooling ecosystem that's there, which is, I think it's really powerful. I mean, I work for Apollo GraphQL. I just changed jobs, so hopefully I don't have a lot of bias, but we're building cool things around there, which makes your life easier. And the other thing, one of the reasons I also created Strawberry is to kind of bring, because GraphQL is used a lot in the Node ecosystem, in the JavaScript community, and I kind of wanted to bring some of those nice things also to Python, and yeah, hopefully I think there's quite a bit of work to do still in Python, in Strawberry especially, but we're gonna get there. In terms of, iQuery performance, it's what was is iQuery?
An optimization for the high query rate situation, so this underfetching where you need to do multiple queries at the same time, or back to back.
Yeah, I mean, you can read these questions in different ways. There are things for example, there is a GraphQL client called Relay where you can have fragments, so you can define every single component on your page, can define the data that it needs. And then there is kind of compiler step that basically creates the GraphQL queries for you, which is really nice because you can basically go deep, and you don't really need to worry about the data where it comes from because in Apollo client or other clients, you need to define the data at some point and then pass it down. With Relays the other way around, which is quite neat. Yeah.
Interesting. Sort of a negative question. When do we, or in your opinion, when do we don't want to use, or when you don't need GraphQL?
Yeah, I mean, I'm definitely biased on that because I mean,
Or is there any case?
No, there's definitely cases. Like, I do use it for everything, mostly because I want to kind of battle test Strawberry and make sure that it works for as many use cases as possible. There are cases, like with simple API, maybe it doesn't make a lot of sense, especially if you're new, if you don't know how to use it. If you don't need an API, for example, you don't need to use GraphQL, obviously. For example, if you're just building a simple website. For example, I have a website, which I should have shown, which tells you the latest version of a software. That's using GraphQL, but that doesn't need GraphQL.
So it's overkill in that case.
Yeah, definitely. It's just for fun. Yeah, so in that case, you should probably not use GraphQL for server-to-server communication. There are the better protocol, better things like gRPC, for example. I mean, some people use GraphQL that way as well, mostly because there is shared knowledge, but it's not the best thing.
I think one issue which I've seen with GraphQL is the fact here that it always returns 200 OK, regardless of whether there's any errors. And there's a question here if there's any way to proxy real status codes and exceptions with GraphQL.
Yeah, so there are different ways of doing that. So I tend to do 401 for things where the user needs to be authenticated, just because you can catch that at the client level, like a global level. You can basically redirect the user to, if you're building a single page application, you can redirect the user to the login page. For errors, there is a good video by Sasha Solomon, which is called 200 OK, which basically talks about how to do errors in GraphQL. So in GraphQL, you're probably going to stick with 200 OK, 200 as a status code, but then you're going to use the types to kind of model the errors. So you have two types of errors. One is the expected errors, and one is the unexpected errors. All the unexpected errors are basically going to make your application crash because you don't expect them. And you shouldn't really think too much about those because they're unexpected. If your backend is down or any of other service, you shouldn't, I mean, unless you want the application to be very resilient, you shouldn't really worry too much about that. And those fall into the errors response. So GraphQL returns data and errors. So you can use that to basically check if there is something wrong. And so you can kind of handle that in a more global way. So if there is any kind of errors, just show a message. And then you have the expected errors, which are basically errors that that they're going to happen. And they usually are the errors that you can compare to 400, the range. And you model those into the schema. So for example, I can have a mutation that create a login for a login. And the return type is not going to be user there. It's going to be a union of user, wrong username and password combination, user bond. And so you can use the return type to basically check what kind of errors you have. And that's quite nice because it allows you to kind of model those on the front end as well, so you can show different things.
Having typing for what kind of error right in the API is quite nice there. Yes.
You can still use status codes if you want, but I think it's a bit more difficult to handle them with like these modern clients on the front end.
Also one question here. You mentioned that one of those fields was actually from a separate API.
Yes.
And it's saying here, if there is one of the data sources, internal request is very slow, would you not receive the GraphQL response until it's finished? And is there a way to handle or optimize that situation? Yeah,
that's a good question. So the first thing you should do is probably adding some caching. So, the second request the requests after the first one, they're going to be faster for sure. There is something that's coming up in the spec of GraphQL, which is called defer and stream. Defer is basically saying, I don't care about this, or I care about this, but I don't need it now. So send me everything else. So for example, for the user query that I had, I can fetch the user, the name, and the age, and then I can also fetch the blog post, but I don't need them to render the page, so I can wait a bit. So the server can send me the user name and age, and then when it's able to, when he's got the other stuff, he's going to send it back. So you get this request in a stream. So first the most important things, and then the rest. This is something that's not available yet in almost any library at the moment, but it's coming up soon. I know that at Apollo they're working on we have a router, which is a gateway for other API. We're going to have support for that at some point, I think towards October. I'm I need to chat with the maintainer of GraphQL core in Python, which is what we use in Strawberry to handle the low-level stuff, to add support for that. I think it's a really cool thing. Yeah.
Seems somewhat of a roundabout way of doing this under fetching, but I'm guessing the optimization is that you just get it when it's ready as opposed to have to write that loop yourself. And should caching be on the resolver level for slow retrieval queries? I guess probably yes.
Yeah, definitely. I know, for example, Facebook, I think they basically cache every kind of entity in memory. I think it's an interesting way to do it, because you know that everything is going to be very fast. With GraphQL caching, it's complicated for sure.
Yeah.
So there are ways of using GET requests to receive data. And so you, for example, instead of sending the query, you send an ID for the query, and then you can cache that with a CDN for sure. So it's more complicated for sure.
Yeah, of course. Also, one thing that's a question about the powers of Strawberry, because in GraphQL you can reference the same resources several different places in the tree. Like you don't in this example, but it can be, and this data resolvers, I think they're called, or data loaders.
Yes.
And it's can Strawberry help with making these, or no?
So we have support for data loaders. We also have support for cyclic references if that's needed. It's a bit cumbersome to use it because of typing stuff and also Python, because you can, if you have a circular import, you cannot do that in Python.
Yeah.
And it's also hard to type something like that, because you need to use if you're familiar with typing, you need to, if you have something that you cannot import but you want to type it, you can use the if type checking, and you can import there. But for Strawberry, that doesn't work because that if is never true at runtime. And so we have a way, which we're going to change it slightly soon, to define a type with the path to the type, so you can do a circular dependency as well.
I see. But this question says, so it's basically, can Strawberry do automatic database patching, or is it still quite statically?
Strawberry doesn't do that. So we do have Strawberry Django and Strawberry Django Plus, which are two projects for Django specifically, which they're probably going to be merged together because we are collaborating with the maintainers. And they have support for, not really batching, but they have support for optimizing the query. So it does select related, prefetch related automatically. And I think it also does select first individual fields as well based on the query, which is quite neat.
Yeah, that'd be good, because it's one gotcha for GraphQL, where if you're querying lots of different things, different places of the tree, then it can be quite
I think
expensive.
the consensus of the best practice, they say that you should use data loaders for that kind of things, mostly because if you do tricks like prefetching or customizing the SQL query, you're tying your GraphQL API to your database, which might be fine, but not be fine if you want to change things or if you want to move things to maybe a different storage layer.
Okay, there's one question here. Maybe it's already been answered, but is there any way to optimize database queries not to fetch Is there any way to optimize database queries not to fetch database fields not in the GraphQL query?
Yes. Yeah. So the info parameter. So this is something that the Strawberry Django Plus does automatically. I think there is also one for other libraries. So there is the info parameter contains all the information about the query, so you can see exactly what field have been requested by the user, so you can make decision about that. So you could send that to your ORM or change the SQL query.
All right. Well, that's all the questions that we have, unless there's any other last-minute questions.
I'm happy to chat after as well. Happy to chat with people during the break.
Yeah, exactly. There's more time for this second break a little bit. So yes, we can finish here. That is true.
Thank you.
Thank you very much.